Welcome back to the Deep Dive. Today, we're unpacking a monumental figure, a person whose life and work, well, it quite literally redefined humanity's place in the universe. We're, of course, talking about Charles Darwin.
And we are going far beyond the standard image of, the bearded Victorian sage. When you really get into the source material, Darwin emerges as this fascinating collection of paradoxes. He was a wealthy, privileged, gentleman naturalist who dedicated his entire life to a theory that just annihilated the privilege of humankind. He was this sickly, sensitive genius, the devoted husband who feared his own intellectual path might separate him from his wife forever.
Absolutely. And think about his trajectory. I mean, he started out as a clergyman in training who was so squeamish, he skipped these gruesome pre-anesthesia medical lectures.
Yeah.
Yet this same man became the meticulous, detail-obsessed scientist who spent 8 years painstakingly classifying every tiny detail of the humble barnacle, just earned the scientific right to publish his earth-shattering ideas.
Our mission today is to track that winding and often agonizing intellectual journey. We're going to follow the clues in the sources, moving from his somewhat directionless youth through that transformative 5-year voyage that gave him all the raw geographical data.
Right, the raw material.
To the moment the pieces finally clicked, that aha moment of natural selection, and then finally to his later, surprisingly varied work that really cemented his legacy. We're using a comprehensive stack of sources covering his entire life, his works, and the profound cultural ripple effect he caused to make sure you get the full context of his great synthesis.
Okay, let's unpack this and jump right into the unexpected beginnings of the man who changed everything. So Darwin was born on February 12, 1809 in Shrewsbury, into a world of, well, serious privilege and intellectual pedigree. When we talk about his background, you just have to recognize the immense influence of his family. The Darwin-Wedgwood clan.
Yeah, they were the definition of 19th century affluence and reformist intellectualism.
And that intellectual heritage is so crucial.
It really is. His paternal grandfather was Erasmus Darwin, a famous physician and an early proponent of these kind of poetic, though undeveloped evolutionary concepts in works like Zoonomia.
And on his mother's side.
His grandfather was Josiah Wedgwood, the pottery magnate, who was also a very prominent abolitionist. This lineage meant Charles grew up around success, science, and a progressive social conscience from day one.
That intellectual and social milieu, it matters so enormously, particularly when you look at his spiritual path.
The family was largely Unitarian, which at the time meant they often favored rationalism and nonconformist views, and they were generally anti-slavery.
But Charles himself was baptized Anglican.
He was, which was politically and socially necessary, especially for his later studies at Cambridge, but he wasn't raised in, a strict high church orthodoxy.
And this foundational environment, it gave him this early passion for natural history and collecting.
Oh, yeah. The sources note his intense interest in the physical world from a very young age. However, his formal education hits a bit of a snag when his father, Robert Darwin, a successful and pretty demanding doctor, sends Charles to the University of Edinburgh Medical School in 1825.
And what a failure that medical career was. I mean, he was supposed to be preparing to follow in his father's impressive footsteps, but the sources just detail a miserable time. Why did he neglect it so much?
Well, there were a few reasons. He found the anatomical lectures just dull and repetitive, and the sheer volume of memorization was overwhelming.
But the critical point was the surgery, right?
Yeah, absolutely. This was before the widespread use of anesthesia. The operations were brutal, they were noisy and bloody, and the sources confirmed Darwin found the suffering of the patients just too distressing to endure. He neglected his formal coursework almost immediately.
I find the silver lining of that neglect so compelling, though. Instead of studying medicine, he dove into natural history, which is where we find one of the most remarkable nuggets about his early worldview.
Right, he immersed himself in practical skills.
And he learned the crucial hands-on skill of taxidermy from a man named John Edmonston.
Yes, Edmonston was an extraordinary figure. He was a Black Briton, a former slave from Demerara in South America who had gained his freedom, settled in Edinburgh, and was earning money by teaching natural history skills.
And Darwin studied with him rigorously.
He did. The sources call it around 40 daily hour-long sessions.
And this was a formative experience, especially given the prevalent racism of that era.
Absolutely. This direct, respectful interaction with a highly skilled, educated Black man, it reinforced Darwin's deeply held early belief in the fundamental equality of humanity. He later wrote about it in his journals, noting the intelligence and shared feelings of people of all races.
And this early anti-slavery conviction, It came from figures like Edmonston and his abolitionist grandfather, Wedgwood.
Yes, and it later became a powerful moral force during the Beagle Voyage, leading to some pretty significant personal clashes.
His genuine scientific curiosity was budding then, too, moving way beyond just simple collecting. He started assisting Robert Edmund Grant, an evolutionist and a prominent Lamarckian, in investigating marine invertebrates.
And this was real hands-on, meticulous work. In 1827, Darwin presented an early scientific finding to the Plinian Society. He discovered that the black spores often found in oyster shells were, in fact, the eggs of a skate leech.
A small finding, but a sign of his observational talent.
More importantly, it was during this period that he heard Grant openly praise the evolutionary ideas of Lamarck, the concept of independent life lineages progressing toward higher forms over time.
So he was exposed to this idea of transmutation really early, even if it seemed, audacious at the time.
Correct. He found the audacity of Lamarck's concepts astonishing. He even admitted he'd recently read similar vague ideas in his own grandfather Erasmus's work. These evolutionary concepts were in the intellectual air, and even though the prevailing view was fixity of species, these early exposures were definitely percolating.
So, since medicine was a complete bust, his father determined to find a respectable career for his son, sends him to Christ's College, Cambridge, in 1828. And the new plan...
Get a BA and become a respectable Anglican country parson.
The irony is just so rich.
It is. Darwin wasn't stellar in the required classical subjects. He aimed for the ordinary degree course, which was much less demanding than the rigorous Tripos exams. He preferred writing, hunting, and shooting to, studying the required texts.
But this move put him exactly where he needed to be, intellectually, for his future path.
It did, because at Cambridge, the hobby became a passion, and the passion became a method. Beetle collecting.
He became zealous, didn't he?
Totally. Influenced by his second cousin, William Darwin Fox. He wasn't just hoarding beetles, he was engaging in rigorous taxonomy. He was so dedicated, he even had some of his finds published by a noted entomologist, James Francis Stevens.
So this period was crucial because it refined his observational skills, his commitment to documentation, and his appreciation for minute variation within species. All foundational skills.
And he fell in with the right people. He became a close friend and protege of the botany professor John Stevens Henslow. This was the circle of parson naturalists. These were men who viewed scientific inquiry as a form of natural theology, seeing the intricacies of nature as the grand design of God.
And this is such a critical baseline to establish for you, the listener. Darwin's mindset was deeply, deeply impressed by the logic of William Paley, particularly his book, Natural Theology.
Paley's famous analogy, the watchmaker. If you find a complex watch, you must infer the existence of an intelligent designer. And Darwin fully accepted this view. Adaptation was proof of God acting through observable laws of nature.
So if he was preparing for the clergy and was convinced by Paley's beautiful argument for divine design, what gave him that burning zeal to drop it all and become a globe-trotting explorer?
Two intellectual forces converged, both pushing him toward empirical investigation rather than, armchair theology. First, the sources note the inspiration he took from John Herschel, the eminent astronomer. His work called for scientists to understand the laws of nature through inductive reasoning, rigorous observation, and generalization.
So Herschel provided the methodology and the motivation.
Alexander von Humboldt's personal narrative of his scientific travels in South America. That book, full of thrilling descriptions of tropical nature and scientific discovery, fueled what Darwin himself called a burning zeal for tropical exploration.
He was so energized, he started planning a trip to Tenerife with classmates.
Exactly. This blend of Paley's appreciation for natural complexity, Herschel's rigorous method, and Humboldt's thirst for discovery made Darwin an ideal candidate for an upcoming immense and completely unplanned opportunity.
He even briefly joined the geologist Adam Sedgwick to map strata in Wales in 1831, proving he was now intensely engaged with the physical sciences, not just bug collecting. He was primed for adventure.
And that engagement was about to be rewarded with arguably the most important journey in scientific history.
So the moment comes right after he returned from his geological work in Wales in August 1831. Henslow, his botany mentor, proposes Darwin as the self-funded gentleman naturalist for the HMS Beagle expedition.
Henslow essentially vouched for him, calling him unfinished but highly capable. It was a 5-year mission to accurately chart South America's coastline, led by Captain Robert Fitzroy.
And the critical detail for Darwin's future career was that because he was self-funded, he was able to retain complete control over all the collections and journals he accumulated.
Yes. Rather than having them appropriated by the Navy or an institution, this protected his ability to research and publish his findings later on his own terms. It was a huge deal.
The voyage itself was brutal in one sense. The sources make it clear Darwin suffered intense chronic seasickness for the whole 5 years.
But paradoxically, that suffering forced him ashore where the real work was done. He spent most of his time inland, constantly investigating geology and collecting specimens.
And while he was doing this, he was reading Charles Lyell's Principles of Geology, which was basically his onboard textbook.
Right, and this introduced him to the concept of uniformitarianism, which was highly controversial at the time.
Okay, let's pause there, because for you listening, this contrast is essential. What was Lyell arguing for, and what was the dominant alternative?
So the dominant view was catastrophism. It argued that Earth's major features, mountains, canyons, and so on, were formed by sudden, short, violent, even supernatural events in the recent past. It fit neatly with the biblical timeline of a young Earth.
But Lyell's uniformitarianism proposed something very different.
It proposed that the Earth was shaped by the same gradual, observable processes, erosion, sedimentation, slow uplift, operating at the same rates throughout immense periods of deep time.
So Darwin went out and just found evidence supporting Lyell's gradual change model everywhere he looked.
Exactly. On their first significant stop in Cape Verde at St. Iago, Darwin found a layer of white seashells embedded high up in volcanic rock cliffs. Now, that wasn't evidence of a flood. It was evidence of slow, continuous geological processes, the seafloor being gradually uplifted over vast ages. He was able to directly confirm Lyell's ideas in the field.
And he didn't just confirm it theoretically. He experienced the concept firsthand and dramatically in 1835 in Chile.
The famous earthquake in Concepcion. The sources describe him living through a massive tremor that destroyed the city of Valdivia. And immediately afterward, he investigated the coastline and saw immediate physical evidence that the land had been raised a significant amount.
He saw mussel beds above the high tide line.
Yes, mussel beds and other marine life stranded. Seeing that instantaneous effect tied perfectly into the larger, slower geological processes he was reading about in Lyell's book, it showed him that tiny changes repeated over eons could reshape entire continents.
This geological conviction led to his coral reef theory, which was actually his first published scientific work in 1842.
Yeah. Based on these geological insights, he theorized that as oceanic islands sank, a gradual process, the coral reefs around them grew upwards toward the sunlight, eventually forming ring-shaped atolls. It was a purely physical, process-based explanation for a major geographical feature.
And it established his early reputation as an eminent geologist.
A necessary stepping stone before tackling biology.
But right alongside the slow grind of geology, the seeds of transmutation, the species question, were being sown by the discoveries in South America. What were the most challenging biological finds?
The fossils in Patagonia were a game changer. He discovered these massive extinct mammal fossils, Megatherium, the giant ground sloth, Toxodon, Glyptodon, found alongside modern seashells.
Which proved two things, right?
Yes. First, that extinction was relatively recent, and second, when Richard Owen later analyzed them back in England, he confirmed they were closely related to living species in South America.
Why is that critical? I mean, why would ancient massive sloths exist in the same place as modern smaller sloths?
Yeah. It challenged the idea of independent creation. If God designed species perfectly for their local environment, why would he create a giant version, destroy it, and then create a slightly smaller, modernized version for the exact same territory?
It supported the idea of geographical continuity.
Exactly. Species being related through the ages, just modified.
He also noticed puzzling geographical distribution among living species, like the rheas.
The rheas, yes. He observed two species of these large, flightless birds, similar to ostriches, that had separate but overlapping territories as he moved south through Argentina. This was a concrete example of the boundaries and varieties of life challenging the simple idea of the stability of species.
These puzzles were chipping away at the theological cornerstone he had learned from Paley.
Absolutely. And then we get to the famous Galápagos Islands puzzle.
The finches.
Well, not just the finches. He found local variations everywhere. He noted that the mockingbirds were allied to the species in Chile, but varied slightly island to island. He learned from locals that the giant tortoiseshells were distinct enough to tell which island they came from.
But famously, he made a crucial error.
He did. He failed to label the finches he collected by island.
That seems like such a massive mistake for someone so meticulous, especially given the weight of the discovery.
It was a novice error, certainly, and it speaks to the fact that he was still learning what was important. He just didn't recognize the variations as significant until later. He thought he had collected a mixed bag of grosbeaks, wrens, and blackbirds.
But the bombshell came later, back in London.
Oh, yeah. When the ornithologist John Gould examined the specimens, he informed Darwin that those diverse birds were actually 12 separate species of finches, all unique to the archipelago.
And that was the intellectual hammer blow.
It forced the realization that all these distinct, locally adapted forms must have shared a single common ancestor which had flown over, landed, and been modified by the distinct environments of each locale. This was the strongest evidence yet for descent with modification.
The voyage wasn't just about rocks and birds, though. It was also about human ethics. We noted Darwin's deep distaste for slavery earlier.
The sources really emphasize his moral outrage. He detested the sight of slavery in Brazil, leading to sharp disputes with Captain Fitzroy, who was a staunch defender of slavery and aristocratic privilege.
And his experience with the Fijian people was also deeply impactful. He contrasted the miserable, degraded savages he met in Tierra del Fuego with the friendly and civilized Fijians like Jemmy Button, who were returning from England after being educated.
And Darwin's observation led him to a groundbreaking conclusion for his time. He rejected the idea of an unbridgeable gap between humans and animals. He concluded that all humans were interrelated and shared a common origin and potential for improvement toward civilization.
But the profound lesson came later, right?
Yeah, it did. When he saw Jemmy Button a year later, the educated man had returned fully to his native lifestyle, perfectly content and thriving. This confirmed for Darwin that environment and culture shape human existence profoundly, not some fixed racial destiny.
So by the time he returned in October 1836, he was already something of a celebrity.
His letters to Henslow had been read to scientific societies and even printed in a pamphlet. He realized the colossal implications of his findings, writing in his notes that if his suspicions were correct about the distribution of life, such facts undermine the stability of species.
He had the evidence for the what change and modification, but he still lacked the how. The mechanism was still a profound mystery that would occupy the next 2 decades of his life. So Darwin returns to London and is immediately inducted into the scientific elite. He's meeting with giants, Lyell, Owen, Babbage. His father, recognizing his son's genius, even organized investments to ensure he was financially secure as a self-funded gentleman scientist.
Which allowed him to dedicate himself entirely to the species question. The pace was relentless. In January 1837, he was presenting his geological findings on the slow uplift of South America to the Geological Society. He was elected to the council, establishing his place.
But he soon started his intensive, systematic speculation on the core problem, transmutation.
And mid-July 1837 is where he began to truly revolutionize thought. He started the famous Bee notebook on transmutation of species.
And this notebook is a scientific treasure map.
It really is. Right there, he sketched his first genealogical branching evolutionary tree, immediately rejecting the linear, progressive model of change that Lamarck had proposed. He noted that it was absurd to talk of one animal being higher than another.
So evolution wasn't a staircase to perfection.
It was a bush of branching, undirected divergence.
He started collecting data everywhere, not just from elite scientists, but from these practical, unconventional sources like farmers, gardeners, and pigeon fanciers who specialized in artificial selection. He was fascinated by how quickly they could mold domestic species to their will.
He saw the analogy, the power of selection to produce variation, but he needed the selective force that operated in nature, a force more rigorous and pervasive than human breeders. The true mechanism eluded him for another year until September 1838.
Okay, here's where it gets really interesting. This is the moment of intellectual lightning, the Malthus breakthrough.
Indeed. Darwin happened to read the 6th edition of Thomas Malthus's seminal 1798 work, An Essay on the Principle of Population. And Malthus's argument, aimed at human society, was stark. Human populations increase geometrically. They double, then double again, 2, 4, 8, 16.
While the food supply only increases arithmetically, 1, 2, 3, 4, the population growth inevitably outstrips the resources.
Which leads to war, disease, and famine, what Malthus called the Malthusian catastrophe.
And Darwin had already been prepared by his Beagle observations to appreciate the universal struggle for existence among plants and animals.
Malthus provided the mathematical pressure cooker that ensured the struggle was continuous, intense, and relentless.
So what was the exact intellectual leap? How did Malthus transform the observation of struggle into the mechanism of selection?
The leap was this. If struggle is inevitable and perpetual, and if variation is constantly present among organisms, which he saw in his pigeon studies, then any small heritable variation that gives an individual even a fractional advantage in surviving or reproducing will be automatically preserved.
And the unfavorable ones die out.
Exactly. This selection is constant, blind, and directed only by the environment, as he famously wrote in his autobiography. Here, then, I had at last got a theory by which to work.
He named it natural selection, explicitly drawing an analogy with the artificial selection used by breeders. He was describing an impersonal, continuous, purely mechanical process based on differential survival.
And this realization carried immense philosophical weight. It moved the divine hand completely out of the process of creation. It was a force like 100,000 wedges trying to force into every kind of adapted structure into the gaps in the economy of nature.
But this profound moment, it coincided with his health collapsing under the immense pressure of his work.
His workload was staggering, writing his journal, editing, and publishing the multi-volume zoology of the Voyage of HMS Beagle, a huge administrative and scientific task, and working on his geology books. The source material clearly links this intellectual stress to the onset of his lifelong chronic illness.
We're talking about stomach problems, headaches, palpitations, trembling.
Yes, and this incapacitation often struck during times of stress, particularly social engagements or major scientific meetings. The cause remained a mystery for his whole life. Maybe psychosomatic, maybe a tropical disease contracted during the voyage.
Amidst this pressure, in 1839, he marries his cousin, Emma Wedgwood. It was a partnership of immense love, but the theological differences were already a source of tension.
Emma was a strong Unitarian, a highly religious woman. She was openly concerned that his honest doubts about religion, especially his theory, which implied the ultimate non-necessity of a creator, might separate them in the afterlife.
And their correspondence really highlights the sincerity of her fears.
And the loving way Darwin navigated this profound intellectual divergence, even as he was drafting the theory that would change everything.
And the domestic tragedy was also ever present. He was a devoted father to their 10 children, but the illnesses were constant. He worried, tragically, that the closeness of their marriage as cousins might have resulted in inherited weaknesses.
And this fear was realized with the deaths of 2 infants, a son who was mentally subnormal, and the devastating loss of his beloved daughter Annie at age 10.
This constant fear and grief fueled his doubts.
By 1844, he had written a definitive 230-page essay outlining the theory, but he kept it locked away. He told Joseph Dalton Hooker that confessing his ideas was like confessing a murder.
So why the long delay? Why lock away the greatest scientific discovery of the century?
It was partly the fear of controversy. The popular but scientifically amateurish evolutionary book Vestiges of the Natural History of Creation was published anonymously in 1844 and faced this huge sensationalist backlash. Darwin wanted to avoid being lumped in with that.
But the main reason, as the sources suggest, was the acute realization that he needed unshakable scientific credibility before publishing anything so revolutionary.
Precisely. He needed to prove he was not merely an adventurer or a theorist, but a meticulous, serious taxonomist. And this leads directly to the monumental 8-year barnacle diversion.
8 years. That's a massive commitment. 1846 to 1854, spent classifying every known species of barnacles, living and extinct. It sounds almost insane given the urgency of his core theory.
But it was strategic. This was Darwin's crucible. In 19th century British science, credibility required deep taxonomic expertise. You had to prove you knew variation intimately. The barnacle, or Cirripedia, was his choice.
And what did he learn from this meticulous, tedious work that was so critical to the origin?
He found the undeniable physical evidence of homology. He was able to trace how different body parts, limbs, shell components had been adapted and changed over time for entirely new purposes. For example, he found species with highly complex reproductive strategies, including minute parasitic males clinging to hermaphroditic females.
So, clear intermediate stages of evolutionary change.
Irrefutable physical proof of modification from a common form. The barnacle study provided the empirical basis for his arguments in Origin about change, variation, and deep ancestry.
It earned him the Royal Society's Royal Medal in 1853 and established him as a biological authority.
And after he finished, he declared, with understandable exhaustion, "I hate a barnacle as no man ever did before." but he had the credibility he needed.
So he finally finished that opus, began drafting his big book on species, Natural Selection, in 1856, confident he had time to perfect it. That confidence, years in the making, was about to be obliterated by a single package from Southeast Asia.
Enter Alfred Russel Wallace. Darwin was corresponding globally with various naturalists, including Wallace, who was working in Borneo and the Malay archipelago. Darwin's long-delayed book was only partially written when, in June 1858, he received an essay from Wallace detailing the exact same theory of natural selection.
Malthusian pressure leading to the preservation of favorable variations. The same thing.
The exact same thing. Darwin was utterly distraught, feeling he had been forestalled after 2 decades of intense, secretive work.
His intellectual crisis was immense.
Fortunately, his close friends, Lyell and Hooker, immediately intervened. They knew Darwin's long history and documentation. They arranged for the immediate joint submission of both papers, Darwin's sketch and Wallace's essay, to the Linnean Society on July 1st, 1858.
And the sources note the immense personal tragedy surrounding that historic moment.
Yes. The day before the papers were read, Darwin's baby son, Charles Waring, died of scarlet fever. Darwin was understandably too distraught to attend the presentation that changed science forever.
And the joint submission was subtle. It barely registered at first.
Right. The Linnean Society president commented that the year had not been marked by any revolutionary discoveries, but the clock was ticking, and Darwin knew he had to publish his abstract immediately.
Following that joint paper with Wallace, Darwin worked frantically for 13 months to produce an abstract of his massive project. It was published as On the Origin of Species by Means of Natural Selection. It came out on November 22, 1859.
And the entire stock of 250 copies was snapped up, immediately oversubscribed, before the day was out.
The book was brilliant because it was presented as one long argument, meticulously structuring all the evidence Darwin had collected over 2 decades.
From the Beagle observations to the barnacle work, the pigeon breeding, the Malthusian logic, the theory was stated simply. Organisms over-reproduce, resources are finite, leading to an inevitable, frequently recurring struggle for existence.
And any favorable variation gives an organism a better chance of survival and reproduction, and this trait is then inherited. It is naturally selected.
The power of the book lay in that synthesis of evidence and the sheer volume of his data. It culminates with that iconic, beautifully written passage.
There is grandeur in this view of life. From so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved.
It offers a mechanical explanation that is paradoxically awe-inspiring.
We should quickly address the language, because it's a detail that's often missed. He uses the word evolved only once in that famous conclusion in the first 5 editions.
Correct. At the time, terms like evolution were typically associated with embryological development or predetermined linear progression. Darwin used descent with modification almost exclusively.
He only added the word evolution to the 6th edition of Origin in 1872.
After the term had become associated with his theory in the public sphere.
In that first edition, he conspicuously avoided explicit discussion of human origins, presumably trying to focus the debate purely on the natural world before tackling the most sensitive subject.
Right, he gave only a tantalizing hint. Light will be thrown on the origin of man and his history. But for the scientific community, the implication was already clear.
Thomas Henry Huxley, his greatest defender, Darwin's bulldog, famously remarked upon reading it, "How extremely stupid not to have thought of that."
Exactly. Huxley understood immediately that the human species was now definitively placed within this natural, unguided process.
The public and intellectual response was immense. Early, prominent scientific critics were crucial, especially Richard Owen.
Owen, Darwin's former collaborator who had confirmed the Beagle fossils, turned into a fierce, sophisticated opponent. Owen promoted ideas of supernaturally guided evolution, arguing that the whole process was predetermined to reach specific forms.
And critically, Owen tried to draw a distinct line between apes and humans, making the false anatomical claim that human brains possess structures entirely absent in apes.
The hippocampus minor. And this led to the famous public dispute that helped solidify Huxley's standing.
The great hippocampus question.
It was. Huxley scientifically refuted Owen point by point, proving that the supposed unique human structure was present in apes. This public defeat severely damaged Owen's scientific credibility and helped bolster the initial acceptance of Darwin's overall argument.
The Church of England's reaction was mixed, though, which shows the complexity of the period.
Yeah. Liberal clergymen like Charles Kingsley were able to accommodate natural selection, viewing it as God's infinitely clever, self-sustaining instrument for creating life. But Darwin's old tutors, Sedgwick and Henslow, dismissed the ideas, worried about the moral and theological vacuum it created.
The cultural flashpoint that most people remember is the 1860 Oxford debate.
An event which, just 7 months after publication, came to symbolize the triumph of science in the public imagination. Bishop Samuel Wilberforce, briefed by Owen, publicly confronted Joseph Hooker and Thomas Huxley.
And Wilberforce famously asked Huxley if it was through his grandfather or grandmother that he claimed descent from an ape.
And Huxley's reply was legendary. He rose and declared that he would rather be descended from an ape than from a man who used his great gift to obscure the truth.
It caused an uproar.
Huge uproar. The debate itself may not have changed the minds of scientists, but it dramatically shifted public opinion toward recognizing the authority of scientific investigation over dogmatic religious authority.
But again, we have to zoom out on the scientific consensus of the 1860s. Most scientists accepted evolution descent with modification as a fact. The evidence was just overwhelming.
But, and this is a crucial distinction, they did not universally support natural selection as the chief mechanism. The problem was that Darwin lacked a theory of heredity. He didn't know how traits were passed on or why variation didn't simply blend away over generations.
And this conceptual gap allowed competing theories to flourish.
This is what later historians called the eclipse of Darwinism. You had neo-Lamarckism, the idea of inheriting acquired characteristics. You had orthogenesis, that evolution proceeded along predetermined lines. And saltationism, that major evolutionary leaps occurred in single, large mutations.
It wasn't until the 20th century, with the rediscovery of Mendelian genetics, that natural selection was confirmed as the primary driver.
Right, which brings us back to Darwin's personal journey of faith, which had been eroding since the death of his daughter Annie in 1851.
The loss of Annie was, for him, intellectually devastating.
He found himself unable to reconcile personal grief with the idea of a benevolent creator. And this grief was coupled with his scientific findings, particularly the problem of evil manifest in nature.
The ichneumon wasp is the iconic example of this.
Yes, the wasp lays its eggs inside a living caterpillar, which is then paralyzed and eaten alive by the larvae as they hatch. This biological horror, this design for exquisite suffering, was utterly incompatible with Paley's beautiful watchmaker god.
Natural selection, on the other hand, explained it perfectly as a result of a blind, competitive arms race.
He still stated that it was absurd to doubt that a man might be an ardent theist and an evolutionist. Yet his actions spoke volumes. He maintained his involvement in local parish work in Down, but he stopped attending church around 1849, instead going for long walks.
And when pressed later in life about his beliefs in 1879, he described his state of mind as agnostic.
He did not claim certainty. He simply maintained honest doubts. But the contrast is powerful. The man who admired Paley's arguments struggled, confessing he couldn't anyhow be contented to view this wonderful universe as the result of brute force.
Despite repeated crippling bouts of illness, the sources eventually link his death to heart disease, or angina pectoris. Darwin's final 2 decades were astonishingly productive.
He pivoted from controversy to deep, often subtle scientific investigation, and finally tackled the most controversial topic of all, humanity.
In 1871, he published The Descent of Man and Selection in Relation to Sex.
His first explicit treatment of human evolution. It was a comprehensive attempt to show the continuity of physical and mental attributes between humans and other animals, drawing evidence from comparative anatomy, embryology, and psychology.
And this book heavily introduced the concept of sexual selection. For you listening, this is a crucial addition to natural selection. What does it explain?
It explains features that provide a reproductive advantage, even if they pose a survival disadvantage. The peacock's plumage is the classic example. Beautiful for attracting mates, but cumbersome and dangerous when fleeing a predator.
So sexual selection is the force that explains secondary sexual characteristics, beauty, display, competition for mates. And he applied this concept directly to human evolution.
He did. He applied it to explain human decorative beauty, differences between the sexes, and even physical and cultural racial classifications. Though he strongly emphasized that all humans are one single species, with a shared, continuous origin.
And his conclusion in Descent of Man is one of his most profound statements.
Man, with all his noble qualities, including sympathy and benevolence, still bears in his bodily frame the indelible stamp of his lowly origin.
That concept of continuity extended to behavior a year later, with the publication of The Expression of the Emotions in Man and Animals. This was pioneering work in psychology.
It was one of the first books to feature printed photographic plates to illustrate concepts. Darwin argued that human emotions, fear, joy, sorrow, were inherited, shared behaviors that evolved because they served an adaptive, communicative function in our ancestors.
He demonstrated the continuity of human psychology with animal behavior, launching the field of ethology.
And both dissent and expression were incredibly popular. Darwin noted with relief that everybody is talking about it without being shocked.
Now, perhaps the most surprising element of his later career, and a testament to his sheer relentless curiosity, was his pivot to seemingly arcane botanical studies.
The source suggests he might have done this partly to avoid the clamorous controversialists fighting about apes and angels and souls. But whether a strategic retreat or a deep personal passion, his botanical work was revolutionary.
It showed the tireless application of natural selection to minute, subtle details. In 1862, his fertilization of orchids showed how the flowers were not just beautiful designs, but highly specialized structures, perfectly adapted to attract specific pollinators.
It was adaptation made visible, and this led to one of his most famous and validated scientific predictions.
The Madagascar orchid.
An incredible story. Explorers sent him this orchid, Angraecum sesquipedale, which had an immensely long 16-inch nectary. Darwin deduced, using his logic of coevolution, that for this flower to propagate, there must exist a moth with a proboscis long enough to reach the nectar.
Otherwise, the flower would go extinct.
And this moth, xanthopan, was indeed discovered and described in 1903, long after his death. It confirmed the predictive power of his theory decades later.
He continued this detailed botanical work throughout the 1870s.
He delved into insectivorous plants, meticulously detailing how species like the Venus flytrap had adapted mechanisms to dissolve and absorb insects. He wrote The Power of Movement in Plants, studying how climbing vines react to light and gravity. His methodology was ingenious, involving countless subtle, inventive experiments in his own greenhouse.
And his final work, in 1881, brings us full circle to geology, but in a very unexpected way. The formation of vegetable mold through the action of worms.
This was inspired by a tiny observation his uncle Josiah had made years earlier, that cinders seemed to be disappearing into the loam. Darwin spent years tracking this, demonstrating the profound geological impact of earthworms.
Proving that the slow, continuous action of millions of worms over vast amounts of time was responsible for leveling ancient ruins and creating topsoil.
It was the same Lyellian logic of uniformitarianism. Small, gradual, repeated action creates colossal change applied to the humble earthworm.
Before we close the book on his life, we have to address the issue of how his ideas were later twisted and misappropriated under the banner of social Darwinism and eugenics.
Yeah. Darwin's personal views were crystal clear and stood vehemently against such political applications. He was a staunch abolitionist and firmly opposed the ill treatment of native peoples everywhere he traveled. He rejected ranking human races as distinct species.
He acknowledged Francis Galton's work on statistical heredity, what Galton later termed eugenics, but he was extremely cautious about applying those concepts to social engineering.
Darwin understood that the struggle in nature was amoral, but when it came to human society, he cautioned that aiding the weak, while perhaps counteracting crude natural selection, was necessary because withholding that aid would fatally endanger the instinct of sympathy.
He called sympathy the noblest part of our nature.
He explicitly insisted that social policy should not simply be guided by concepts of struggle and selection found in nature. He drew a firm ethical line against the later movement that tried to use his name to justify inequality and ruthless competition.
Charles Darwin died on April 19, 1882, likely from heart disease. His last words, the sources note, were filled with love for his family, praising their care.
And though he had expected to be buried locally in Down, his scientific colleagues recognized the epochal scale of his contribution. They successfully petitioned the government for him to be honored with burial in Westminster Abbey, placing him close to scientific giants Isaac Newton and John Herschel.
And his legacy endured that eclipse of Darwinism following his death, when support for natural selection waned.
It did. It took the 20th century to finally vindicate his core mechanism. When scientists like Ronald Fisher incorporated the rediscovered work of Mendelian genetics, they created the modern evolutionary synthesis. And this synthesis confirmed that natural selection, operating on genetic variation, was indeed the fundamental, universal mechanism of biological change.
So if we synthesize this incredible journey for you, the key takeaway is the meticulous, almost inevitable path from detailed observation to revolutionary theory. It wasn't one blinding revelation, but a chain of connected insights forged by tireless work.
And that synthesis involved three critical steps. First, the shift from theological acceptance to geological conviction, thanks to Lyell, convincing him of deep time and gradual change.
Right. And second, the puzzles of the beagle, the geographical continuity of fossils, the two species of rheas, and the varying finches that suggested species were fluid and shared a common ancestor.
And the final critical piece of the puzzle, Thomas Malthus, who provided the brutal mathematics of population pressure that transformed artificial selection by man into the vast, undirected power of nature.
And this genius was underpinned by his relentless, often surprising research, whether it was the 8-year grind on barnacles to gain scientific authority or his decade-long deep dive into the arcane life of plants, the adaptation of orchids, the movement of climbing vines. He was always building evidence.
His true genius lay in his ability to see seemingly disparate facts, rocks, fossils, barnacles, worms, as components of one single unifying process.
His discovery remains the single most important unifying theory of the life sciences. As the geneticist Theodosius Obzhansky famously put it, nothing in biology makes sense except in the light of evolution. It provides the framework for understanding all unity and diversity in life on Earth.
It's powerful, but it's also challenging because we're left with the immense philosophical dissonance that troubled the man himself. Darwin noted that he couldn't anyhow be contented to view this wonderful universe as the result of brute force, yet his life work systematically stripped away the need for divine intervention in the creation of species. He replaced design with mechanism.
And this internal struggle, it raises a critical question for us now. If Darwin, the architect of this elegant, self-sufficient theory, still wrestled with the philosophical implications of a lawgiver versus purely brute force, what fundamental challenge does evolution still pose to our modern philosophical and ethical frameworks? If we accept the continuity between humans and animals, what new mysteries are we still trying to solve using the logic of natural selection, particularly in areas like the evolution of human consciousness, morality, and complex social cooperation?
Those are the ongoing deep dives, all launched by the observations of a curious, sickly man who hated lectures but loved beetles.
Powerful indeed. That's Charles Darwin, the evolutionary architect, and that was the deep dive.